Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Irfan Daniel. So today I will show you guys how to calculate BMI using LabVIEW. So here we have two forms that we need to fill. First is weight and second is height. So the result here will show BMI result and the category. Here we have three categories. We have normal, overweight and obesity. So I will show you guys how to use it. So for weight, you change it to 50, and the height we are gonna use 150. So just run continuously, and the result will show BMI result. BMI result is 22.2222, and the category is normal. And after that, change the weight to 60, and the height is 155. So the BMI result here is 24.97, and the category here is overweight. After that, change the weight to 80, and the height is 160. Okay, so here the BMI result is 31.25, and the category here is the obesity. So when we are using LabVIEW, it is very easy to calculate the BMI. So I think that's all from me.
Okay, for the mini project, we take reading from three devices. That is oscilloscope, multimeter, and lastly the view. Okay, for the oscilloscope, we have two channels. First, we use on the heel, and then the second channel we use it on the fifth metatarsal. Okay. For the multimeter, we connect it to the heel too, and we'll show the data by. Okay, and then lastly we use LabVIEW to collect it for all the sensor. Okay, that's all on how we take readings from our devices. Okay, this our show the function by showing. As I standing here, the view for the oscilloscope for the heel and the fifth metatarsal shows about 4.9 and 4.9. This 4.9, and lastly the view show about the view of 4 about 4.9 and somewhere like that, so that it's consistent with the other readings on the device.
Discuss about the calibration of the sensor and how to calculate the state of error. Okay, so over here, we have about 5 sensors, and each sensor is calibrated, is connected to the LabVIEW through a DAQ component. So we have 6 graph chart, each one representing each sensor except for this one, because this one is where we collect all sensor into one graph chart. So this chart will generated different this will generated signal for each sensor. Meanwhile, all the other graph chart will only generated one signal for each sensor. So we have a heel, we have 2 left, we have mid right, 2 right, and mid left. All right. So this is how we place our sensor. We put it on something like a shoes. So each one, we have 5 sensor. Each one is connected in a voltage divider on a breadboard, and then we will calibrate it. We will connect it to oscilloscope, multimeter, and LabVIEW. So this is how it looks like when load is being placed on sensor. This one we got heel, sensor for heel, sensor for two left, sensor for mid right, sensor for two right, and the mid left. And this is how the signal of all sensor being displayed in one graph chart. So this is the reading that we got from the calibration process in oscilloscope, multimeter, and LabVIEW. The same goes to this one. Okay, so now we're going to discuss about the error state. Why do we need the error state? Is because when we run experiment, we usually will set up the expected outcome before we got an actual outcome from an actual experiment. And from that, we are going to see how much the error that we have made, whether in the process when we are expecting it, like calculating, making a theory, or when we run an actual experiment and collect the data from it. So here the definition, we usually use force error. We usually calculate force error in a percentage form. It is determined in a percentage. So we have this one is called uh, predicted force, and this is a reference force. Predicted force is usually we predict it before we run experiment, and reference force is the data that we get from the experiment. So we put predicted force and minus it with reference force, divide it with reference force, and times 100 to get the percentage rate. I'm going to show the example. This is the example of the data. So here we got the predicted force, and this is the actual force that we get from an actual experiment. So to calculate an error, we will simply take the predicted force, minus it with the reference force, divide it with reference force, and then that is how we got error force. This is going to help us understand further on to find the problem in our project, to make sure that the data that we collect from the experiment is accurate.